All right, we're looking at midpoint and distance in a coordinate plane. So midpoint we've kind of talked about a little bit before, and it is a halfway point in between a segment. So if I have AB, this point M is the midpoint, where it's halfway through. So we're going to talk about some formulas for midpoint and then a formula for distance as well. Number line is pretty straightforward. If I have these two parts, I need to find halfway through. So I add them up. So A plus B and divide it by 2. And that's going to equal our midpoint. In a coordinate plane, which is where we're going to see this a little bit more often, we have a point here, and we're going to call this point x1, y1, because remember the coordinates an x and a y value, and we just use the 1 to identify that they go together. So x1, y1, and then we have our other point x2, y2, and our midpoint's halfway on there, which is a coordinate. So to find the midpoint for this, we're going to write it as a coordinate, and we take our x values for both of them, x1, and we add it to x2, and then divide it by 2. We're kind of finding the average, or halfway in between there. And then we also do the same thing for our y value, and we do y1 plus y2, and divide that by 2. And that is a coordinate. That'll end up being a coordinate for our midpoint. So let's look at a couple of examples with that. On our number line, remember we take our two values. I have a -4, and I add it to 10, and then we divide it by 2. And this is going to give our midpoint. -4 plus 10 is 6, so we have 6/2. And 6 divided by 2 is 3. So our midpoint, if it was right here, it would be at the point 3. Now let's look at an example of doing this with a coordinate plane. With this, you're going to want to be very organized with it. And what I do is, even though I have my coordinates here, I'm going to write them out. I'm going to do -2, -2, and we have 3, 3, and we want to find the midpoint for both of those. So once I write them out, above them, I'm going to label them with that x1, y1, and x2, y2. Now again, the first value is always the x, and the second one's always the y. But x1 and y1, because they go together, they're part of the same coordinate. x2, y2, because they are part of the same coordinate. Then what I'm going to do is I'm going to take my formula up here, and I'm just going to plug in those values just like I see them. So x1, we said, is -2, plus x2, which we said is 3, all divided by 2. And then we do the same thing for our y values. y1 is -2, plus y2, which is 3, divide that by 2. Then all we do is simplify this. -2 plus 3 is a 1/2. And then our y value, -2 plus 3 is 1/2. You can leave it as that fraction, or you could write it as a decimal, because that simplifies to 0.5, 0.5. Either one of those are acceptable. I'll put an or in between them. So our midpoint's going to be somewhere right in here, from those 2 points. Now let's look at a little bit different example. It says C is the end point and M is the midpoint. What is the other end point? So it'd probably be down here, but we don't know what it's going to be. So we're going to use some algebra with this to figure out what this other endpoint is. Now we're going to use our same formula for midpoint. this one up here. But let's put in what we know. So we're still trying, let's say we're trying to find our midpoint. This is going to be like our x1, y1. This negative 2, 2 is our x1, y1. So our x1 is negative 2 plus x2, but we don't know what that x2 is. We're going to solve for that in a minute. And then that's still divided by 2. Our y2, or our y1, sorry, is a positive 2 plus whatever our y2 is. We don't know that yet. All over 2. So once we have this set up, now we know that the x-coordinate for our midpoint is 1. And we know that our y-coordinate for the midpoint is negative 3. So we're going to set up 2 equations to figure out what this part, the x2 value is, and what the y2 value is. So as we said, we know negative 2 plus x2 all over 2, that's going to equal the x value right here, which we said is 1. We're going to solve for x2 by using our algebra skills. Also, we're going to use this 2 plus y2 over 2, and we know that's going to equal negative 3. So we'll use algebra to solve for that. Let's go through these then. This is division. We have to actually undo that first. And so remember, to undo division, we're going to multiply both sides by 2. When I do that, that cancels out. And we're left with negative 2 plus x2 equals 1 times 2, which is 2. We want to get x2 all by itself. This is a minus 2 or subtracting 2. So we're going to add 2 to both sides. These go away. We get x2 is equal to 2 plus 2, which is 4. So our x-coordinate for this other endpoint is going to be a 4. Now we're going to do the same thing to find out the y-coordinate. We're going to, again, multiply both sides by 2. These go away. We're left with 2 plus y2 equals negative 3 times 2 is a negative 6. Here's a positive 2, so we're going to subtract 2 from both sides. Those cancel out. We get y2 is equal to negative 6 minus 2 is a negative 8. So now we have our x and our y coordinate, and we will write it as a coordinate for negative 8. And there is our solution. This other endpoint is going to be at 4, negative 8. And that does look like the midpoint to that point. All right, so now let's talk about a distance formula. Now our distance formula that we're going to use, and we're actually going to use this quite a bit, is the square root of x2 minus x1, and then we square it, plus y2 minus y1 squared. It's the difference of our x values squared plus the difference of our y values squared, and then we take the square root of all of that. So if we're looking for the distance between this point A, which is negative 3, 5, and the point B, 5, 7, we are going to use this formula for that. Now, you can do it like this, or I'll show you another way to do it. What I would do is label this x1, y1, x2, y2. We always want to label those first. We can write them out on the side as well. x1 is a negative 3. x2 is 5. Y1 is 5, and y2 is 7. Now all we do is we replace the values in here with what we know for our coordinates. So we do the square root of x2, which is 5, minus x1, which we said is a negative 3. We square that, plus y2, which is 7, minus y1, which is 5, and we square that. And so let me show you how we simplify this now. So let's first do what's in our parentheses. 5 minus a negative 3. Remember, minusing a negative is the same thing as addition. So 5 plus 3 is going to be an 8 squared, plus 7 minus 5 is 2, and we square that. Now we go through and find those. 8 squared is 64, plus 2 squared is 4. 64 plus 4 is 68, and we take the square root of that. This is going to be our most exact answer, and sometimes I'm going to say to leave the answer exact. And if it's an exact answer, it's going to be just what's under the square root, because this is not one of our perfect squares. So sometimes you can just leave it like this. Or you may see round it to the nearest hundredths. So we do our square root of 68, and we get 8.2, and we'll round that up to 5. So it's about 8.25. We can kind of put those little squiggly equal signs. So it's pretty close to that. Either one of those is going to be acceptable.